It was almost exactly a year ago, the biggest science story of the century. It was a mystery about what was happening inside a lump of metal inside a test tube. But the mystery was not just about the elements in the test tube, and perhaps the major effect of the bubbling tube was not to be on science itself, but on the way we perceive it. The first remarkable thing about the story is that almost everybody who heard about it, scientist or not, heard about it on the same day.
Whoever said great scientific dreams come in large, expensive packages? Instead of experimenting with giant machines costing millions of dollars, a British and Utah scientist may have found the answer to our energy problems in a glass tube.
More people have seen these pictures than watched the moon landing 20 years ago. On March the 23rd of last year, the University of Utah held a press conference for the two scientists to explain their amazing discovery.
This experiment has to be approached with some caution, because this device, if this device worked as rapidly as the small-scale electrodes which we've run, this would be generating about 800 watts of heat.
Martin Fleischmann, Professor of Chemistry at the University of Southampton, Fellow of the Royal Society, renowned for his imaginative and brilliant work in electrochemistry.
We've established a sustained nuclear fusion reaction by means which are considerably simpler than conventional techniques.
Stanley Pons, Dean of Chemistry at the University of Utah, one-time student of Fleischmann, a man with a reputation for outstanding experimental work. Pons and Fleischmann were announcing their discovery to the press before they'd told even their closest colleagues. They were to feel the effect of that decision for the next year. But for now, word was out. Two respectable scientists said that inside an ordinary test tube they could make nuclear fusion. By now, everybody has heard of fusion. It's the nuclear process that powers the sun. It's the power of the hydrogen bomb. It's also a way of extracting energy from ordinary water.
The promise of virtually unlimited radiation-free energy is something that is worth spending perhaps billions of dollars on.
It had been on everybody's mind. It was on television every night. Global warming, ozone layer, the greenhouse effect. The Exxon Valdez oil spill story had actually broken on the same day. Most of the time, when we think about these disasters, we're reduced to despair. This time, perhaps, somebody was offering a real answer. Soon we might all have safe, small fusion reactors. No more greenhouse effect, no more fossil fuels, no more global warming. The possibilities were tremendous. If Pons and Fleischmann were right.
I subscribe to the views of Karl Popper, Sir Karl Popper. He says you can never prove anything right, you can only prove it wrong. And I think we have to go now through a phase where everybody will try. We have tried very hard to prove ourselves wrong, all the way down the line. We have to now wait and see, are we right? What's the scope of this? And only the future will show where it fits him.
Karl Popper's process of checking a theory began on the American early evening news, at a time when labs were closed and their occupants, outside Utah, were enjoying a drink.
Martin Fleischmann and Stanley Pons found a way to simply fuse deuterium.
Electrochemists were startled to see their colleagues on the TV newscasts.
Stan and I thought this experiment was so stupid that we financed it ourselves.
The scientists were attempting for the...
At MIT in Boston, one of America's most prestigious science universities, the people who reacted first were the youngest, the undergraduates.
We got pretty excited about it. We talked about it for a long time, finally decided, let's do it. It was around 11:30 at night. We ran around the corridors looking for the materials we needed. It was sort of a scavenger hunt.
It was the excitement of being at the forefront of what might become a new technology, of saying I was there when it first happened, of trying to verify the claims of another scientist when those claims seemed, outrageous.
We probably didn't really believe it was going to work. I guess we knew that our attempt at it was sort of a slipshod attempt. We knew that wasn't going to work, but I think we did really want to believe.
It wasn't difficult at all because it's a very simple experiment that any chemistry student would learn in their first year. So it's just finding a jar, a battery, and this palladium, and that's all really you need to do.
It's a breakthrough in an area that we've been spending a lot of money and putting a lot of effort into. It's a clever, cheap version of something that people have been piling, lots and lots of effort into. Instead of, it's the sort of thing where, the entire nation is working at getting fusion to work, and they have these huge generators, and they have, the one at MIT has a whole row of municipal power generators devoted to it. They have their own special cable going over to Cambridge Electric Light Company. They get blamed if there are glitches in the power line from other people because everybody assumes that it's them. This is high power, big science. And then here come along these two electrochemists and say, oh, yeah, we'll just do this, poof, fusion in a jar. That appeals.
Perhaps the appeal was not appreciated by those whose livelihood depended on the funding of the big machines that were the basis of humanity's previous attempts to sustain a fusion reaction. They had been spending billions on magnets as big as a house, producing temperatures as hot as the sun, and still their own PR handouts talk of decades before they have a working reactor. What they have in common with Pons and Fleischmann is that they both use a constituent of water as a fuel, a heavy form of the hydrogen nucleus called a deuteron. Fusion is when two deuterons meet and rearrange themselves to form a new atom and eject a particle. The rearrangement can take several forms, but the result is always the same. A new atom is formed and energy is produced. Normally, deuterons will fuse only very rarely. You'd expect only one fusion a day in the whole of the galaxy. The heat and pressure of the sun drives the particles together until fusion is happening all the time. The reaction becomes self-supporting, and energy flows out of the system. Previous attempts to produce fusion on Earth concentrated on trying to reproduce the conditions of the sun. Three things have to be achieved. The temperature has to be high enough, the pressure has to be high enough, and the conditions have to be maintained for long enough. So far, these three have never been achieved together. Pons and Fleischmann offered hope that a special trick would remove the need for all that. Cold fusion claimed to use a strange property of the metal palladium. It can absorb deuterons like a sponge soaks up water. A cube of palladium can actually bulge with deuterons. Fleischmann and Pons claimed that they could make fusion happen by packing the deuterons inside the metal using an electric current. The bubbling was to be expected, but they said that after a while heat was produced. The tube was a source of energy. They also said that they had detected exotic nuclear products, neutrons, gamma rays, tritium. These were an unmistakable sign that fusion was taking place. The MIT undergraduates didn't find anything, though. They hadn't seriously expected to, but they had started MIT's cold fusion research effort. A photograph of their evening's work found its way to senior plasma fusion scientist Marcel Godreau.
Late, I guess, that Friday, we were kind of like at the end of the day, Friday night, and it's the Easter weekend, so everybody's kind of leaving, and there's a little bit of chatting in the hallway. And lo and behold, one of the guys right there came up with this little piece of paper here, and it basically described an experiment the Picot people had done in one of the labs, and I was just like amazed. I thought it was a very good, very quick experiment. Now, for something that was done the night of the press conference, is very good. It had all the basic ingredients, palladium, and the heavy water, and so on. And it described how they measured the temperature, and they had a little picture. It's kind of like a page in a notebook, and I think this will be something in our archives for a long time. I think it's really what got me really going. I saw this and said, hey, these guys are really rolling, and we ought to really try to figure this thing out. We'd spent years and years working on control fusion, and then suddenly you have this little jar like this, and we ought to figure out how this works.
I thought this experiment was so stupid that we financed it ourselves.
There was no published paper from Pons and Fleischmann to go on. It was impossible to contact them, so some of the world's most eminent fusion scientists ended up getting their data off a TV screen.
Okay, stop it there. Okay, now this is kind of like to the right of the experiment. And then you can see the three tubes. These are just regular tubes charging. And the good thing about it about this picture is you can actually see the wires clearly in series. Wow, it's hard to see a little bit, but if you take some time, you look in there, you can see this wire goes around like this.
She's got like 4 cells there, and 3 here and 1 in the water bath.
And the thing that we don't understand is this tank.
It's not hooked up to anything. Or is it?
And how long does the charging go on? I mean, if they look at energy balance, if you get back to the question of energy...
They wore out a tape trying to work out the wiring of the batteries.
I mean, you have to know how much energy you've put in, integrated energy you've put in.
In fact, the batteries were irrelevant. They were just there to power a detector. But they didn't know that. A little more information came from one of the older media. Martin Fleischmann had spoken to a journalist on the Financial Times. The father of one of the team was arriving from London the next day.
And the next day I had to pick up my dad at the airport, and he had the Financial Times. And, he made me aware of an article and said, what do you think about this? My dad is not a scientist, and we always have a little exchange. And I looked at it and said, that sounds so easy, I think I'm going to try that.
A printed diagram, even from an unusual source, made it seem more likely that they could reproduce the experiment. During the weekend, the group worked round the clock looking for heat and fusion products. At first, the team practically expected to see something glowing straight away, but nothing happened.
From the news reports, we got, sketchy details, and one of them was that you have to have a rather thick palladium rod. So the first thing we did on Monday when the shops were open is to try and dial around and find a palladium rod, which proved to be not such an easy thing to do. We got the last palladium rod in New England. We had to drive up there and get it ourselves. And that evening, all of us were working in a team together. But we were so excited that we stayed up all night.
One of the strongest pieces of evidence for the amount of radiation to expect was the fact that Pons and Fleischmann were still alive. That put a maximum on the quantity of fusion products. It was still sensible to take precautions, though. Ironically, the safe area was under the nuclear reactor. The team kept watch on the experiment by a TV monitor. They worked on for days, but still no glow and no explosion.
We really were realizing there were just too many degrees of freedom. Even you would think that once you knew what it looked like, that, well, how complicated can it be? Well, if you just look at what power you needed, you didn't know the voltage, you didn't know the current, you didn't know if it was pulsed. Even if you knew it was pulsed, you didn't know it was pulsed quickly, how often it was pulsed, and so on. The solution, well, had an infinite number of variables, because even if it was just one chemical or another, there's thousands of chemicals, maybe it was a combination of chemicals. So there's just, literally, we're realizing that we needed more information.
At the British Nuclear Research Establishment at Harwell, there was a group that had a distinct advantage. A couple of weeks before the press conference, Martin Fleischmann had actually given them details of the experiment. Pons and Fleischmann had claimed to measure the heat that was essential if their effect was to be a source of energy. But to claim fusion, they had to prove that this was a genuine source, not just a rearrangement of the power already put in. They had to detect the particles that are ejected during fusion, mainly neutrons or perhaps gamma rays. The Harwell work covered both heat and fusion products, but their search for neutrons was particularly thorough. They placed bubbling cells in the center of concentric rings of detectors. They also had to be sure that no other effect would interfere with the result.
Well, what you have to do is compare a powered cell with an unpowered cell so that you can get rid of the effects of variations in the background and funny effects due to the counter and all that kind of thing. You have to exchange them every 5 minutes, and you have to do it for hours and hours and hours, and it is unbelievably boring. Now, we did it like this for the first couple of runs because there was a panic about repetition of the results from Brigham Young University. But obviously we then automated this process, and it just shunted backwards and forwards there, in and out, every 5 minutes for weeks.
Okay, that's it. 385, 392.
You don't do science unless you have a sense of vocation.
405 and 366.
When you get gripped by something like this, you work all night. I mean, people do it. And the telephone was just going like crazy. The reporters ringing up every 2 minutes. One reporter from a popular newspaper, he wanted me to tell him that everybody was going to have a little immersion heater in the corner of their room and this was going to solve the energy problems. Well, I wasn't going to say that. I think people were gripped by a great sense of excitement. And one of the things that you notice with things like the cold fusion and the high-temperature superconductors is all of a sudden there seem to be huge numbers of scientists who have free time, who are able to do things like this. And I reckon that what it is that all of the time here they are, they're meeting their milestones and their targets and all this kind of stuff. And all of a sudden something like this happens and they're released. And it's like away they go on this fantastic chase.
After a few weeks with still no result, Williams tried to call Fleischmann, who was, after all, a friend of his, to ask what he thought might be going wrong.
After this press conference, things, I don't know, I think things were probably difficult for Martin, and the amount of communication that we could have was less. And Martin said, and I think rightly, that he wanted any confirmations to be independent confirmations. So we didn't have a lot of contact. I did let them know that we were getting negative results, but we didn't really have a proper opportunity to discuss exactly what we'd done and why it should be negative. I think that kind of thing takes a lot of time to explore and get right. And I think Martin, after this thing exploded, Martin simply didn't have any time.
Discussion with Pons and Fleischmann would not have been so crucial if a full paper had been available for study. The community of scientists has its own way of doing things. Even the most earth-shattering discovery should be reported in a learned journal, usually the British magazine Nature.
We like to think that we publish the most important scientific discoveries that people make, from the discovery of radioactivity at the turn of the century to the discovery of the positron, the neutron, the splitting of the atom in the early 30s, the discovery of nuclear fusion in 1939, DNA in 1953, continental drift between then and 1962 when it was tied up. And we have a very, very good record in that field. And so I think people, our readers, look to us to provide authentic reports, in the words of the authors of research, of important discoveries.
Every article submitted to Nature goes through a checking process called peer review. The draft is sent for assessment to various experts in the field. Pons and Fleischmann had submitted an article the day after the press conference. The experts came back in record time with requests for more detail.
We sent them these comments. As I remember, the paper went through two series of revisions. The first produced a paper that was still unsatisfactory to the referees, and we asked them a second set of questions, telling them, look, we don't care how long the paper is. We want these questions fully dealt with. And they decided, I think it was quite legitimate on their point of view, that they didn't have the time to do that. They had so many other things to do.
Pons and Fleischmann did publish a paper in another journal. It was faxed around the world. Faxes of faxes were passed on to everybody who was interested until people were receiving illegible copies. But Maddox had been right. Their paper satisfied almost no one. It answered none of the questions that would-be fusioneers needed to know. But information, or at least opinion, had by now burst out in the form of electronic mail. Every lab in the world is connected by computer links. This is the marketplace chatter of the scientific community.
Since I'm living in the Netherlands, I can't get these 16 files by anonymous
Physics grad students here at the University of Washington have detected signs of tritium, possibly produced
scientific technology. But I'm a CS major at a small university, and we don't talk.
One of the most interesting things about the CNN broadcast last night was that the man explaining the experiment to the reporters was touching the glass bulb containing the active elements. None of his bodily parts fell off. By the way, all you fusion skeptics, could you shut up for a while? I think it's pretty clear that there is cold fusion going on.
I have as much right to be skeptical and to talk about it as you have to believe
You're right, you can have a big laugh at the rest of us in a month or two.
At the beginning of April, cold fusion was used in one of the traditions of broadcasting.
The time is 17 minutes to 8. 3 English schoolboys have become the first team in the world to repeat the nuclear fusion experiment carried out by two distinguished scientists last week. This week, a young team from Merchant Taylors' School in Hertfordshire has done it.
I thought it might be interesting to try. Other people were going to be doing it, so why shouldn't we?
How long was it before you actually got a flash on the spinthariscope?
2 days, I think it was. It was a long time of watching before we actually saw anything on the spinthariscope.
In 2 days, 3 schoolboys and their physics teacher had become the first to repeat the Fleischmann-Pons experiment.
The whole group of us, we were just ecstatic. It really was. It was a marvellous feeling.
That report by Dominic Arkwright. The date, the 1st of April. The time just going up now to 12 minutes to 8.
Exactly a week later, the joke was for real.
New promise, puzzle, and mystery tonight over what may be a momentous advance in fusion nuclear energy research.
Researchers in Georgia and Texas said today they've duplicated parts of the Utah experiment that created such a tempest in a test tube. The claim that nuclear fusion can be achieved at room temperature. And researchers at Texas A&M University say their experiment, like Utah's, produced excess energy. Georgia Tech scientists say their experiment produced high levels of neutrons, confirming nuclear fusion is taking place.
It's so fantastic that simply to confirm it is a major thing. There was a literal explosion of interest. There were so many cameras all of a sudden. I thought, surely there must be a plane wreck on campus somewhere, but as it turns out they came to photograph us, this very room here.
The Italians, French, and Swiss announced they're trying to duplicate it. Scientists in Moscow, as usual, claimed they'd already done it 20 times at least. Georgia Tech is rechecking its numbers, but researchers in Texas and the University of Washington say they've been partially successful. No matter, since the word broke, the price of palladium, the metal used in the experiment, has soared $30 an ounce. And the University of Utah, where it all began, has a growing list of Fortune 500 companies wanting a piece of the action.
By the 27th of April, 24 labs were known to have reported some sort of confirmation. Nobody knows how many had actually tried the experiment. As fusion fever increased, the University of Utah started to work on raising funds for further research and exploitation. They employed a firm of consultants to persuade congressmen to support special emergency funding.
American scientists at Raytheon invented the microwave oven, but today it's Korean and Japanese companies who produce 90% of the world's microwave ovens. American scientists at RCA invented the color television, but today European and East Asian companies produce over 97% of the world's color televisions. American scientists at Ampex invented the VCR, but today Japanese, Korean, and European companies produce over 99% of world VCRs. American scientists funded by DARPA invented the computer numerically controlled machine tool, but today European and Japanese companies produce over 75% of the world's computer numerically controlled machine tools. American scientists at AT&T, Bell Labs, and Texas Instruments invented the base technology that produced the world's first memory chip, but today over 80% of memory chips produced.
Are you aware of any attempts by the Europeans or the Japanese scientists to develop viable cold fusion?
This is being researched around the world, and I've had confirmation of our results from far afield, very far afield. You can guess where that might be.
There is an alternative, and that's what I'd like to talk to you about today in the remaining few minutes. It's an alternative that says that America is prepared to fight to win this time.
In Utah, fusion fever took on a kind of party atmosphere. A definitive collection of T-shirts will one day be a valuable element in the annals of scientific history. But there were still problems. Of the two signs of fusion, heat and nuclear products, some groups saw heat and some saw nuclear products. Very few reported that they'd seen both. This was partly because it was very difficult to measure the two at the same time, but also because it required sensitive measurements that were subject to error. There were even rumors that in Utah a physicist had tried to measure neutrons in Pons and Fleischmann's own lab, but had found nothing. The fusioneers started to become a little defensive.
No camera. No cameras, no tape recorder.
Even the groups that reported results reported that they were irreproducible. Sometimes it worked, sometimes it didn't. Nobody could explain this, and it just made cold fusion a slightly less scientifically respectable phenomenon.
Without these exact facts, we will never be certain that our samples have reproduced their samples.
I beg your pardon, the background is available in the corrections to the paper.
That might be. I would like to specifically hear whether or not helium...
Don't
Could we go on? Could we go on to the questions, please? This experiment hasn't been reproduced by any national laboratory or any university yet without a good football team.
Mudslinging on television is not going to get any of us anywhere.
Zero-energy thermonuclear assembly, or ZETA, is used by British scientists at Harwell in a tremendous project.
Some critical scientists recall the British phenomenon of the 1950s.
Atoms of deuterium are fused together to form helium atoms with the consequent release of fantastic energy. Deuterium is obtained from hydrogen and hydrogen from water, so one day we may get unlimited power from the sea.
Within 3 weeks, embarrassed scientists had to admit that they'd made a mistake, and the Holy Grail was still missing. BF3 counters were still to be in use 30 years later, reduced in size so that they could be moved. Quite how they were moved turned out to be a crucial factor in the career of Jim Mahaffey.
But we were talking, as it turned out, one evening with some guys at Lawrence Livermore out in California. They had exactly the setup we had, using the same type of detectors, same water bath and whatnot. And they were doing the same interim control that we did, which is you take the detector out of the moderating solution and put it behind the boron blocks, thus shielding the detector from any neutrons made in the experiment. We had done that. We found that when you put the detector behind the neutron shield, neutrons fell off to background, which seemed to confirm that whatever was going on in the cell was making neutrons. They did the same thing, only whereas I picked it up by the cable daintily like this, one of the guys held it in his fist. And as he held it in his fist, you noticed the neutron count going up. You thought, that's odd. So they got a heat gun and played it over the tube. They found the neutron rate would go up just like it would in the experiment. And we were on the phone with them. They said, you better check your BF3 tube. So we took it out and put it in a glass of simple hot water. And in fact, it went up times 600 over background. At that point, we said, gentlemen, we are dead. It's not nearly as dramatic and conclusive as what we thought we had. The press reaction to that was maybe 7 times greater than the initial press reaction. Whereas at the first conference, I think there were 7 cameras. At the second conference, there were 30 cameras, all trained on me. Had to explain what had gone wrong. It was a very interesting time to be alive. I remember having heard about a conversation where someone said Georgia Tech was actually paid off by the oil companies to suppress the data. Well, the oil companies never approached me on that. I'm still available, ready to suppress just about anything if the price is right. But they never even tried.
Despite the setback at Georgia Tech, researchers have kept their sense of humor.
Let me just tell you that we've renamed the experiment the Shroud of Turin.
Harwell reported similar experiences with neutron counters. In one case, a faulty plug registered a massive surge. In Spain, a group found that they could increase the count simply by opening the window.
Measuring neutrons was interesting to me. I'd never known anything about it before. I mean, I guess as most chemists might think, that you just go and get a neutron counter out of the stores and you point it at whatever the source is supposed to be, and you look at the counts, they're registered. And it's not like that at all. I mean, it was pretty impressive to me, the rigour with which the experimental physicists went about this particular job. There turned out to be lots of reasons why you get signals on neutron counters which have nothing whatsoever to do with the presence of neutrons.
In Boston, MIT reported that they could find neither heat nor fusion products.
the Utah University Department of Cold Fusion Confusion. Fill cup with desired beverage. Insert swizzle stick. Clip wire to swizzle stick and insert other end of wire into cork on end of test tube. Guaranteed to work unless you are from Boston or have any affiliation with Boston physicists.
We worked for 5 years on this, and if people think that they can go and have a quick dabble and find the result, then fine, let them do that. But that's not our style. Our style is to do definitive experiments over a long period of time. And we disapprove of the way in which
experiments
are being done at the moment.
Papers written at lunch and published negatively that evening. It doesn't happen.
We've sat for 5 years on this, and I think the people who are doing the work should respect that.
But the most serious blow to cold fusion didn't come from any experiment. It came when an MIT physicist looked at Pons and Fleischmann's own data.
In a paper released today, the MIT scientists concluded that a major part of the Utah claim is wrong.
One piece of information was on television as well as in their paper. It caught the attention of an expert in gamma rays. The trace on the screen was meant to be evidence for gamma rays, a fusion product. But Richard Petrasso pointed out that it looked wrong. It was too narrow and it didn't have a characteristic bulge called the Compton edge.
If you have a real gamma ray, then this other edge, called a Compton edge, must exist. Must exist just as certainly as if you were to give a ball and if it doesn't drop, it must drop. That edge must be there. So those two fundamental points negate the possibility that they really observed this characteristic fusion gamma ray. There's also a third feature, and that is that the peak is much too large compared to the background radiation. We know, because their lab is on Earth, that there's these characteristic gamma rays that come up from the ground. In this case, it comes from uranium-238. It's around here, and no matter where you go, England, Europe, America, uranium is in the ground. And this causes background radiation. And this background level should have been far more elevated with respect to their signal size than they show. So we knew from that consideration alone that the energy had to be wrong.
Since this became public, no group has claimed to have detected fusion products in the quantities that Pons and Fleischmann originally claimed. Cold fusion research did not receive federal funds, but the Utah State Legislature still had enough faith to vote a $5 million grant to be made for a national cold fusion research institute. $4.5 million were for staff and equipment. $500,000 was for fees for patent lawyers.
We're, of course, at this stage engaged in phase one of the work, which focuses primarily on the basic science issues, the operation of cells either in a Pons-Fleischmann format or 2 or 3 generations of design beyond the Pons-Fleischmann type of cell.
The director of the institute was quoted in the press as saying that they hadn't got any results yet. It was quickly explained that he'd been quoted out of context. He was not available for comment when we visited the institute, which had by then adopted the policy of not discussing results.
Basically, it's far too early. What we are seeking to do is to basically gather significant data, that is statistically significant data, on the experiments that are being conducted currently. When we have such data accumulated in sufficient detail, then at that point we would be more prepared to make our results public.
So far, no papers have been published, but work continues at the Institute and in labs all over the world. A curious fact about the geographical distribution of cold fusion discoveries was noticed by a scientist who was writing an article about the story.
I was absolutely astonished that when I took Northern Europe, Northwestern Europe, all the results were no, 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 no. They couldn't find it. And when I took Southern Europe, it was all yes, yes, yes. When I took Eastern Europe, it was all yes, yes, yes. The United States divided into 2 groups. If you took the major laboratories and what I call the region of the greater region of the New York Times, where it was read very much, it was all no, no, no. If you took the remainder of the United States, the southern part, it was all yes, yes, yes. If you took the rest of the world, it was all yes, yes, yes. And this rather horrified me because it suggested that the result you got depended upon where you lived and where you worked. But when I went through the numbers, the statistics were absolutely overwhelming.
Coming from the University of Utah, we're in the western section of the United States, not surrounded by many other major universities. We're not the usual stopping place for any of the national press in terms of regularly reporting on science work from the university other than genetics or artificial organs. The big research centers that deal with this area are on the East Coast or the West Coast. So there's also the isolation involved, and there are some here who've thought that had we been a Berkeley or a Stanford or a Caltech or an MIT, that the announcement might have been viewed a little differently.
Wherever they were made, the confirmations of cold fusion were all announced much sooner than the negative evidence. Douglas Morrison has a theory about why that is.
I think the reason is when a very interesting, exciting discovery is announced, there are many people start working. And if, for example, you have 100 people start working on it, perhaps 50% do careful experiments, find nothing. Another 50 do experiments and, they're not quite sure. But 10 of them, just by this sort of fluctuations, they find positive results, and results come out. And since they find a positive result, and it's already been published, then it's a confirmation, and they don't have to be critical because just confirming something. So they announce no problem, they hold press conferences. Great. Whereas the 50 who found nothing and who do a good experiment, they're worried. Because to say a colleague is wrong is very dangerous. I mean, because maybe you're wrong, so they worry and they're reluctant to publish. It takes time, they check and say, well, maybe there's some secret we have to check on. So they're slow. So in the initial period, you only get the confirmation of that. Then gradually one or two have the courage to publish, and then suddenly a lot more publish. Then suddenly everyone realizes that it can't be right. And there's this avalanche of results that have been waiting comes down.
In spite of the avalanche, a number of labs continue to report some sort of results, but they are still beset with problems. Some groups detect small amounts of fusion products, some detect occasional releases of heat. None detect both at the same time, and no group detects anything every time. There probably is some unusual scientific effect going on, but whatever it is, it has now lost any claim to be a source of energy. Scientific claims, at least, are susceptible to a final judgment. Time and painstaking research will eventually reveal the truth. But until then, everything else is just an opinion.
No, I think you have to invoke a nuclear process, or a set of nuclear processes. Of that I'm quite convinced. I'm as convinced now of that as I was in March. So I think you have a responsibility to say, here are our results, and this is what I think it means. The detailed nature of that, of course, you asked me before, is it fusion? And I said, well, it is a nuclear process, a set of nuclear processes, maybe fusion.
I think it will turn out, after 2 or 3 years more investigation, that this is just spurious and unconnected with anything that you could call nuclear fusion, thermonuclear fusion. I think that, broadly speaking, it's dead, and it'll remain dead for a long, long time.
So what happened? What went wrong? Everybody was worried about the environment, but why should that have led the University of Utah to announce the discovery by press conference? There's no suggestion of fraud or cheating. It seems likely that it was a combination of particular pressures. A clue is to be found in a story that happened 4 years before the press conference, about 40 miles from Salt Lake City at Brigham Young University, where a group led by Stephen Jones has also been working on cold fusion for 5 years. Shortly after the press conference, Jones circulated an account of the events which had led up to it. This is his version. In 1985, one of Jones's group had become interested in a geological puzzle, why the Earth's core is hot. Theory said it should have cooled down by now. Somebody suggested fusion. Jones and some colleagues discussed the idea. As was their normal practice, they took the notes of their meeting to the university lawyer. Jones prepared a soup of all the chemicals he knew would be inside the Earth. He then did the same as Pons and Fleischmann. He packed deuterons into metal with an electric current. There's no record of any heat, but they did seem to find neutrons. Few, but enough to note on July the 4th, 1986. Jones first heard about Pons and Fleischmann in 1988. He was a referee for a grant application of theirs. He called them and invited them to visit his lab.
And they visited, just the two of them, no lawyers. And they visited with us. We had a very enjoyable chat. We showed them our neutron spectrometer. Indeed, we showed them our data, and in that we showed them the evidence we have for neutrons. We have more evidence since, but we showed them what we had at the time. They were very excited by that. I don't think they understood that it was really a very small amount of neutrons, but we tried to discuss that, but I'm not sure that was completely getting across to them, but they were certainly very excited by the evidence for fusion in the electrolytic cells.
At a meeting between the universities, they eventually agreed to simultaneous publication of their separate results. Pons and Fleischmann wanted to wait for 18 months. Jones insisted that he was obliged to publish now because his results were ready. They finally agreed to submit papers to Nature on the 24th of March. But on the day before that, the press conference was called.
We listened to the press conference with interest. The comment was made, I think, more than once. Boy, we're really glad that we didn't end up working too closely because their nuclear physics obviously wasn't real solid at that stage, and we hadn't realized that they were thinking along these grandiose lines.
Of course, with hindsight, one would prefer not to have had all this brouhaha. One would have preferred a quiet life. But if you have the results which we had in February of this year, and then going into the beginning of March, there's no way you could hide those results. That had to be published. Maybe published, I would have preferred to have backed it up with some further work, but it had to be published.
Pons and Fleischmann were convinced that the phenomenon they had discovered was fusion on a scale that might be a source of energy. The university was making patent applications. Pons and Fleischmann wanted more time to continue their work, but the university wanted an announcement and patent applications to be made. It seems clear, having learned about Jones, the university was anxious to beat him to a patent application.
We would do all in our power to have this exploited by ourselves and others for the benefit of cheap energy with little cost to the world's ecology. We would also like it to come to the benefit of the economy of Utah. That's not always easy to guarantee because ideas aren't contained by borders, but perhaps ownership and patents are.
We had written a number of patents by that stage, and the view of the university was that it was correct to announce this via a press conference. It was really the patents which were driving this.
My own feeling is that cold fusion represents more than anything else the American dream. I think cold fusion is the epitome of American dream. I think that Thomas Alva Edison would have been proud to design and invent a gadget such as the gadget that is supposed to make this fantastic source of energy. It has all the symptoms of an American dream. It's the new world, it's a revolution overnight, getting rich overnight, and doing something against the understanding and against the consensus of what our scientific society is. My own feeling is that the American dream turned into an American nightmare.
The nightmare of a year's legal and commercial pressure must have had an effect on the smooth running of the scientific process.
My own belief is that Pons and Fleischmann, for a very particular reason, had come to nurture a delusion about what was happening. Remember that they had been working on this project for 5 years before they had their press conference. They'd been convinced at an early stage that they were observing fusion, and much of their later work was an attempt to confirm this by measuring neutrons and gamma rays. And they were convinced that this discovery was going to be of immense importance, as indeed it would have been if it were true, and was going to make a great fortune for somebody, themselves included. And so they kept it very secret. As a consequence, they were entirely isolated from the natural day-to-day skepticism of the scientific community, and they didn't get the help from the scientific community that they would have gotten. So, in my opinion, they were able to nurture this delusion that they were measuring fusion only because of the secrecy that they had themselves imposed on their work.
Because of the intense public interest in this, and what is obvious also, I guess in the States, the commercial interest in this as well, the patent lawyers are in all the time on this, that this exchange of information has not taken place. And so what you're left with is almost like a religious dispute. You have a group of people who believe very strongly that cold fusion exists, and then another group of people who believe very strongly that it doesn't exist, simply because the two have not been able to talk to one another in a way which would allow them to resolve the similarities and differences between their experiments.
I did see a bumper sticker that said, "Be merciful to electrochemists, as they know not what they do."
A few days ago, I got to thinking, gee, it's a shame Richard Feynman isn't alive to see all this cold fusion stuff. He would have gotten a big kick out of it. Assuming that cold fusion goes the way of polywater and N-rays, who gets the jars?
All of us in the industrialized world are already using too much energy. Think about it. Couldn't you live with a smaller house, with one or no car per family, with just one product of detergent, with half of your plastic equipment? Don't tell me you can't.
If I throw a match into a box of gunpowder, I get more energy out than I put in, too. Could this mean something?
I guess it is time to close down this forum. Any objections?